Hello, Math 20-1s, and welcome to our second online lesson for Trig. So this lesson is going to be on section 2.2, but I've actually broken 2.2 up into two separate segments. So we're going to do the first one this week on finding the trig ratios for any angle. And then we're going to do the second portion, which is about angles or special triangles, next week. Okay? So we've kind of got two goals in this lesson. The first is to determine the distance from the origin of a point, any point, that's on the terminal arm of an angle. So we're going to combine the stuff we just learned in 2.1 on angles and standard position with some of the things we know about trigonometry already. And then the second thing is that we're going to find the value of the three trig ratios for any point on the terminal arm of an angle. All right? The third one there, which I don't even know is in your notes, I've scratched off because we are not doing the third one. Remember, we're simplifying this down to the most important stuff. All right, so let's get going today. So let's suppose that we have theta as an angle in standard position, and we've got this point P on the terminal arm, and it is some distance from the origin, and we'll call that distance R. So I've already sketched this out, right? So we've got P here, and so its coordinates are x, y. So x obviously is your horizontal, y is your vertical, and then we are some distance r from the origin. So what have we created? We've created a right triangle. And what formula then would we use to find the value of r? Anyone? Anyone? You are correct. We are going to use Pythagorean theorem. I know somebody said it, so don't worry. So we are going to use Pythagorean theorem. And so, as I'm sure you all remember, Pythagorean theorem is that a squared plus b squared is c squared. That's the actual formula for Pythagoras' theorem. And a and b, of course, are just the arms of the triangle, and c is the hypotenuse. So in this case, our arms are the x and the y, and our hypotenuses are. So how would we find r? We're going to take x and y and square them. And x and y you would get from the coordinates of the point. And if we added them together, that would equal r squared. And so just to get r, we are going to square root those. Or square root the sum, rather, and that would get us r. So that's our first point covered. How do you determine the distance a point is from the origin? You use Pythagoras' theorem. Awesome. So let's move on then and combine that with the trig ratios that we know. So last week, you reviewed the three primary trig ratios of sine, cosine, and tangent. And you remembered that sine is the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse, and tangent is the opposite side divided by the adjacent side. So we're going to combine those ideas of basic trig with what we've just established now for a point on a terminal arm of an angle. All right, so if we're thinking about theta here, all right, well, what's the opposite side to theta? Well, that's y. What's the adjacent side to theta? Well, that's x. And of course, we've already talked about how the hypotenuses are. So that means that we can then rewrite the three trig ratios like this. Sine theta is equal to the side y divided by r. Cosine theta is x divided by r. And tan is y divided by x. Okay? And if you don't have those memorized, that's okay. You can always figure them out from the picture. Right? As long as you've got your three trig ratios memorized, which you should because you know SOHCAHTOA, then you're good to go. So let's take a look at an example question. All right, so here we go. We've got a point, 5, -2, lying on the terminal arm of an angle in standard position. And we are being asked to find sine theta, cosine theta, and tan theta. Now, watch the language there, you guys. It's asking for the ratios. So we are not actually finding the angle. This question is not asking us to find theta, just to find the ratios. All right, so in trig, good idea. This is all so visual. Sketch it out. So sketch out where this angle in standard position is. So start off with your coordinate grid. And then, okay, well, where's 5, negative 2 going to be? Well, we know that's going to be positive 5 on the x-axis. Actually, let me just change this over so we were just looking at the work. All right, let me clean this up just a wee bit. All right, let's start again. So let's sketch out our coordinate grid. And 5, negative 2, okay, well, that's going to be 5 on the positive x-axis and negative 2 on the y-axis. So 5, negative 2 would be about here. Okay, now what is our, so that's a point on our terminal arm. And so what is our actual angle here? Well, remember, angles in standard positions start from the x-axis. So our principal angle would actually be this. So this would actually be theta. Now we can't really work with that because that obviously isn't going to create a right triangle. So what we are going to work with is the reference angle. So we're going to work with this piece. All right, so we are actually going to work with the reference angle. And so if we create a right triangle here, well, we know this side is 5. We know that side is 2. And we need to figure out the hypotenuse. Well, we already talked about how we would do that. R is equal to the square root of x squared plus y squared. Well, x is 5. Y is negative 2. And we're going to square root that. And so what would we get? Well, 5 squared is 25. Negative 2 squared is 4. So 25 plus 4 is 29. So r is equal to the square root of 29. Now we are not going to turn that into a decimal because 29 is a non-repeating, non-terminating decimal or irrational. And so we would have to round it. And that would give us an estimated value, and we don't want an estimated value, we want an exact value. So we're just going to leave it as root 29. All right, and now we can move on to finding the 3 trig ratios. So sine of the reference angle is equal to the opposite side divided by the hypotenuse. Well, the opposite side is negative 2, and the hypotenuse is root 29. So that's our ratio for sine theta. Cosine, again, of the reference angle, is the adjacent side divided by the hypotenuse. The adjacent side is the x value, 5. Hypotenuse is still root 29. So 5 over root 29 is our cosine. And lastly, tangent is the opposite side divided by the adjacent. Opposite side we already have gone over is negative 2. Adjacent side is 5. So tan theta is equal to negative 2/5. And we're done. That's that simple, okay? We just need to figure out the hypotenuse using Pythagorean theorem, and then we've got it. So not so hard, right, guys? That's why I thought we could do this one too. All right, let's move on then. So normally I would get you guys to try this. So try with point negative 3 and negative 4 lying on the terminal arm of your angle and find cosine, sine, and theta. Now again, you can sketch this out, and for those of you that are visual learners, I strongly recommend it, but I also know that some of you just prefer the algebra, just prefer almost getting right to it. So remember we said, so first you're going to have to find r, of course. So we've already reviewed how to do that. So r is equal to the square root of x squared plus y squared. So in this question, x is negative 3 and y is negative 4. So we're going to square those and take the square root. So negative 3 squared is, of course, 9. Negative 4 squared is 16. 9 and 16 are 25. And that means that our r is actually 5. Perfect. So we also had reviewed just the shortcuts essentially, right? Sine theta, and if you need to go back and just quickly look at the note, what did we say sine theta was? We said it was y divided by r. Excellent. So y divided by r, y is -4. R we just found was 5. Cosine theta is x divided by r. So -3 divided by 5. And tan is y divided by x. Or in this case, -4 divided by -3. And we all know that a negative divided by a negative is a... That's right, it's a positive. So tan theta is actually equal to 4/3. So you can do it just that way as well. You don't have to sketch it out if you don't want to, but for those of you that are visual, and I, quite frankly, I normally do, because I like seeing it, right? Because then I don't have to memorize which one's x over r or y over r, or right? Once I've sketched it out, I can just see it, right? But just wanted to show you that you could do it that way as well. All right, let's take a look at another one. So this is worded slightly differently. Right? So suppose theta is an angle in standard position with the terminal arm in quadrant 3, and tan theta is equal to 1/5. Determine the exact values of sine. All right, so I'm going to sketch this out again, just because, as I said, that helps me see it. So my little coordinate grid, what information do I know from the question? All right, terminal arm is in quadrant 3, so somewhere over here, right? So that means we're going to be working with the reference angle again, right? So we're going to work with the reference angle to create a right little triangle there. So tan theta is equal to 1/5. Well, what does the tan ratio tell us? It tells us the opposite side and the adjacent side, right? Tan theta is opposite over adjacent. And in this question, we know that's 1/5. So that tells me the opposite side is 1. Great, so that side's 1. And the adjacent side is 5. Okay, but that doesn't quite line up with what I know about the coordinate grid. I know that for an angle in standard position when the terminal arm is in quadrant 3, right, what should the values of my x and y be? Well, they in fact should be negative, and we can see that, and this is again why drawing this out helps us, right? My x should actually be -5 because I've gone to the left of the origin, and we've gone down 1, so my y should be -1. But of course, like, there's nothing wrong with what the question's been written, because what is a negative divided by a negative? Right, a positive. So we would have simplified tan theta to +1/5, because it would have actually been -1 divided by -5, and a negative divided by a negative is a positive. All right, so now we've got that. Now we just need to figure out r, and r is equal to x squared plus y squared. So in this case, -5 squared plus -1 squared. -5 is, of course, squared is 25, -1 squared is 1, so we are working with the square root of 26. Again, do not square root this and make an estimate of the decimal value. Keep it as a radical. Okay, now we have been asked to find now just sine theta. Well, sine theta is the opposite divided by the hypotenuse. The opposite side is -1. The hypotenuse is root 26. So -1 over root 26 is sine theta. There we go, done. Okay? So this leads us to something that's helpful to know, which is something called the cast rule. The cast rule, as it says, is a strategy that will help you remember when each of the trigonomic ratios is positive or negative, because we've seen that now in couple of these questions, right? So here in this question we saw that tan was positive in quadrant 3, because the negative x and a negative y canceled out and we're left with a positive. However, the sine of theta was negative 1 over root 26. In the previous question, we saw that as well, that sometimes sine and cosine could be positives and sometimes they could be negatives, right? In this question, we have sine being a negative number, we have cosine being a negative number, but we have tangent being a positive number, right? And in the question before that, we saw cosine was positive, but sine and tangent were negative. Okay, so the CAST rule summarizes this for us, right? It helps us remember in which quadrants are each of the trig ratios positive, okay? So this is the CAST rule. So in quadrant 1, everything is positive, right? Because both your x and your y are positive. R, by the way, your hypotenuse is always a positive. It doesn't matter what quadrant it is. And we see that because when we square negative numbers, we always get positives, right? And when we take the square root, we actually, in fact, only take the principal square root. So I should have mentioned that when we actually took the square root of 25 in this question, it's not plus or minus 5. We just take the principal square root, so the positive one. Okay. So here we see that in quadrant 1, both x and y are positive. So all of your trig ratios are going to be positive because your hypotenuse will also be positive. However, in quadrant 2, you're going to have positive y's but negative x's. So that's going to mean that some of our trig ratios are going to be negative here. The ones that involve x will be negative. In the third quadrant, both x and y are negative. So now we're going to find a few more trig ratios are negative. And in the fourth quadrant, your x's are positive, but your y's are negative. Okay, so let's try to think then, what would that mean then for each of the trig ratios? So which quadrants are we going to find sine being positive? Now remember, sine involves the y value and the hypotenuse. Okay, so quadrant 1, where everything is positive, we're going to have a positive sine value. And then the other one we are going to have is where y is positive. So that means quadrant 2, we would also have a positive sine value. Where would what quadrants would cosine be positive? Well, of course, quadrant 1, because everything's positive there. Now, quadrant 2, remember, cosine involves x. So in quadrant 2, the x is negative. So cosine will be negative. In quadrant 3, x is still negative. So cosine will still be negative. But in quadrant 4 here, our x is back to being positive. So we are going to find a positive cosine when the terminal arm is in quadrant 4. Tan is positive then, of course, quadrant 1, because they all are positive in quadrant 1. But remember, tangent involves the adjacent and the opposite, so both x and y. And the only way to get a positive is for both of your numbers to either both be positive or both be negative. So in quadrant 1, they're both positive. In quadrant 2, one of them is negative, so you'd have a negative tan. In quadrant 3, though, they're both negative. And we saw that in the last question. We had a negative x and a negative y. That gives us a positive tangent. So all of them are positive in quadrant 1. That's what the A stands for, all. In quadrant 2, cosine is positive. Or sorry, not cosine, sine is positive. That's why the S, sine. In quadrant 3, tangent is positive. And in quadrant 4, only cosine is positive. And that's where we get the letters for the CAST rule. C-A-S-T, CAST. You do need to remember that CAST starts in quadrant 4, or you need to remember that the A for all is quadrant 1. And we always go in a counterclockwise way with the coordinates in trigonometry. Okay, so that's where the CAST rule comes from. So again, that's just a tool that we're going to use to help us remember where the ratios are positive in what quadrant? All right, so we've got a couple more examples and then we're done. So the value of tan, and I'm just going to switch again over just to the main screen just so you can see the whole thing. Okay, the value of tan theta is 3/4. The value of the sine is negative. What is the exact value of cosine theta? Okay, well, we need to think about that for a second. What quadrant would we have a positive tan value but a negative sine value? Again, go back and take a look at the picture of the cast rule then. So it can't be quadrant 1 because everything's positive in quadrant 1. In quadrant 3, tan is positive. Only tan is positive in quadrant 3. So that means the sine would be negative. So our angle, theta then, our terminal arm must be in quadrant 3 for tan to be positive. So again, tan is equal to the opposite divided by the hypotenuse, the opposite divided by the adjacent. So that 3/4 then gives us basically our point on the terminal arm. Right, so this must be -3, our opposite side, and this side is -4, our adjacent side. We are looking for the cosine of theta, so that means we are going to need to find the hypotenuse. So again, we know how to do that. We find the hypotenuse by finding the square root of x squared plus y squared. Our x is -4, our y is -3. -4 squared is 16, -3 squared is 9, 16 plus 9, 25. Square root of 25 is 5. So what's our cosine theta then? We can add this now, we know the hypotenuse is 5. So what's our cosine? Well, cosine is adjacent divided by hypotenuse. Our adjacent side for theta, our reference angle is -4, and our hypotenuse we just found was 5. So -4/5. Okay? Those of you that are obsessed with decimals, yes, you could turn this into -0.8, but why? That's just another step. So you can just leave it as -4/5. All right, another example here. The terminal arm of an angle theta lies somewhere in the interval of 90 degrees and 180 degrees. So again, just a slightly different way of wording this, right? The value of the sine theta is 1/2. What is the exact value of cos theta? All right, well, the angle lies in between 90 and 180. So what quadrant is that going to be in? Quadrant 2, you are correct. So our terminal arm is going to be somewhere here. There's going to be a point on the terminal arm. And of course, theta then, we are in reference to the reference angle. So again, we can make a right triangle here. Wow, that's not the best right triangle I've ever drawn now, is it? Let's try again. Right triangle. Okay, this time we know that sine is 1/2. And if you remember the cast rule, right? Cast rule I just made that mistake. Cast rule, C-A-S-T. In quadrant 2, we would expect sine to be positive. Now what does sine tell us? Sine tells us the opposite side divided by the hypotenuse. So this time we know the hypotenuse is 2. We know the opposite side is 1. So now we have to figure out the adjacent side, not the hypotenuse this time. Okay, well this time we know the hypotenuse is 2. So we're looking for one of the legs of the triangle, so we would actually do 2 squared minus 1 squared and square root that, and that would get us our x value. right? I'm going to do r squared minus y squared, and that would give me what x squared is, so square root that. 2 squared, of course, is 4. 1 squared, of course, is 1. 4 minus 1 is 3. So our x value is the square root of 3. Now we've been asked for the exact value of cosine. All right, well now that is not so hard anymore. Cosine theta is equal to the adjacent side divided by the hypotenuse. We just figured out what the adjacent side was. It's root 3. Hypotenuse is 2. So root 3 divided by 2 is what cosine is. All right. One last one that, again, normally I would have you guys do on your own if we were in class together. So how about pause this video right now and try this one on your own. Okay? Go ahead. Come on. Pause it. I said pause it. All right, so now you're back. Great. So just to quickly go over this, make sure that you got this correct. So determine the exact value of sine theta given that the point 0, 2 lies on the terminal arm of angle theta. All right, so again, sketch out my coordinate grid. 0, 2. Where does that lie? 0, 2 lies on the y-axis. So what is the angle that we are dealing with? We are actually dealing with 90 degrees. Right? Okay, well, that seems weird because we know the angle already, but let's talk about the ratio. So our point here, of course, is 0, 2. We are looking for sine. Right? Well, what's sine? Sine is the opposite side divided by the hypotenuse. Or, as we've seen in this lesson, sine can also be expressed as the y value divided by the r value. Okay, well, our y value is 2, so we just need to figure out what our r value is. And again, that might seem a little odd because we don't really have a right triangle here, right? But I mean, just think about it from the mathematical point of view, right? R is going to be x squared x squared plus y squared, take the square root of that sum. Well, y is 2, so 2 squared, x is 0, so 0 squared. So we are going to have the sum of 0 squared plus 2 squared, which is going to be the square root of 4, which again is 2. So r is also 2. So sine theta would be 2 over 2, or 1. And if you don't believe me, check with your graphing calculator. All right, so let's do that. What is the sine of 90 degrees? Sine 90 sine of 90. No, wait a second. One second, something that's always important to check, and there I see it. I am not in degree mode. Make sure your calculators are in degree mode for trig, right? If not, you are going to get all of your trig answers wrong. So let's try that again. Sine 90 is equal to 1. And I know that's true. That's why I knew when I typed it in the first time that I had something wrong. Okay, so yeah, sine of 90 degrees is equal to 1. The opposite side and the hypotenuse are the same thing, right? All right, my lovelies. That is it for this lesson. So if you have any questions, you know that we're going to meet for Google Meet next week. Try some of these questions that I'm going to assign you that are written in your assignment section there. And I will see you next week for any questions you have. Okay? Take care, guys. Bye.